In the previous session, we have started with the module 2 in that chapter 5, process scheduling and basic concepts we have finished, in which what is the difference between CPU burst, IO burst, and how to calculate CPU burst and IO burst together. So then we have seen also the CPU scheduler, okay, what all the activities a CPU scheduler should do, and how to maintain preemptive activities set and non-preemptive activity set. So dispatcher means one who dispatches the process for execution. Also the process who has completed their execution, those are dispatched out of the job queue. Okay, so some of the 4 points scheduling criteria we have seen for 5 points. CPU utilization, total number of time CPU allocated for a process. So throughput, number of processes completed per unit time. Generally it is measured in terms of MIPS, million instruction per second. So then comes turnaround time. So turnaround time means, so the total time suffered or total time taken by a process to get executed, which includes also the waiting time. Okay, so next question is waiting time. The waiting time is time taken by a process not executing, but it is waited for some resource. Okay, either maybe the resource of a variable or maybe the resource called CPU cycles. So the response time means how fast the system will give the answer back to the user. So that's a response time. So we have seen schedule algorithm optimization criteria. We have to think always maximization of a CPU utilization, also the increasing the throughput. So decreasing the turnaround time, waiting time and response time. These are the 5 parameters. Okay, so let's start the problems one by one. So this first let me give the name of algorithms. We have some algorithms. First come, first served. I repeat, first come, first served. So short form is FCFS. So this generally we are using in everywhere there is a queue, like visiting a temple, getting a ticket to some of the movie, okay, getting a train reservation seat. So everywhere we will get this concept of FCFS. So first take a 3 processes. Okay, so each process has following CPU burst time. So that means 24 seconds first process, 3 seconds second process, and 3 seconds third process. So here if the question is of FCFS, there will be attached one more point along with the table. So in which order they arrive. Why it is important? Because the name of algorithm itself is we should able to solve or provide the service for who will come first. Only for that we have to provide the service. It is not like pick anyone and give the service. Okay, so along with that the order of occurrence is given or arrival is given. How the processes will arrive? First P1 will arrive, then P2 will come and P3 will come. So here we have one technique called Gantt chart. I repeat, Gantt chart, through which we will try to solve how the processes are arranged and executed. So actually it is a 2-dimensional graph, x-axis against y-axis. Here y-axis we are not mentioning, just x-axis is important. So this x-axis will gives us time as the period, or time as the measuring value. Okay, listen, very important how to write this. So generally what we have to do is we have to draw this rectangle. Okay, don't put these vertical lines, even the last line also please don't put. Okay, so only starting line you put and followed by the 2 parallel lines. You can take only 1 row or 2 rows of your answer booklet or the notebook. Okay, 2 rows or 1 row is also sufficient. Okay, now first question, how to draw this? Once I draw one vertical line, I will assume that as a 0th time. This is a time axis, x-axis is time. So this I assume it as 0. So now if I allow according to the order, what is the first process will arrive? P1. So he will enter in the first box. I have to write P1. So how much time process will take to complete its work? It is 24 seconds. By imaginary I assume 1 2 3 4 5 like that, 22 23 24 I assumed here. So 24 is somewhere here. I will put it a line. So this line indicates P1 completion. Please remember. So this line indicates P1 started. P1 started. Okay. P1 starts at very first time interval and ends at exactly 24th time interval. Okay, next. Once I finish this, what is the next? I have to check. I have to check who is arriving second, who is after P1. So after P1, what we have? P2. So I will write here immediately P2, but I don't know where to stop. Starting is fixed, that is 24. Where to stop it? So here what I do is, for 20 up to first 24, who has took the space? P1. After 24, how much time is required for P2 is 3. So what I do? 24 plus 3. So here somewhere around 27 I will get. I will put one vertical line which indicates P2's completion. Please repeat. P2's completion is 27. P2's starting is 24. So P2's execution is from 24 to 27. Okay, coming for the next, very important. So what is one more order remaining after solving P1 and P2 is P3. So I will put right here P3. So I don't know how much I know how when it is starting. It is starting at 27, which I already know because that is the end of P2. So I don't know how much it is when it is going to end. So how to identify when P3's end? When P3 started plus P3's burst. So 27 plus 3, 30. So I will take up to 30. I will put a vertical line. So if there is an extra line, I will remove. Hope it is clear now. I will read out once again. Put two parallel lines and write one vertical line towards your leftmost and call it as a 0th line. Consider the order in which first process is P1. Write down P1 and go on counting some numbers randomly. It is not like measuring exactly with a scale or pencil. Okay, some random. By looking into this, we should feel 3 means this much and this much. 8 times of P2 is P1, like that. Okay, geometrical shapes. So little big because it is taking for up to 24, as we can see here as 24. Once you write somewhere 24 here, put one vertical line which indicates a P1 completed. I repeat, P1 completion is 24. Okay, next, once a P1 is completed, next comes is what? Here you see the order P2. So write here P2. So from where to where P2 is, how to check is, once you write a P2, here is a starting value of P2, that's a 24. 24 plus P2's total duration, 24 plus 3, 27. So somewhere here I will put a vertical line that shows end of P2. Left of P2 is vertical line that shows start of P2. So P2 is completed, 27. So after P2, what is there in the given order? P3. So P3 will be here. I hope P3 will be here. So it started at 27. 27 plus this 3 is a 30. Hence I will close here at 30 and put one vertical line. That finishes Gantt chart. Now, how to calculate waiting time? So what is the definition of waiting time? The process occur for execution and the computer is busy with some other process. Okay. Now when this first Gantt chart allowed a P1, who was there before P1? Nothing. It was empty. So P1 waiting time is 0. So when P2 should, how much time P2 is waited from the beginning? P2 is waited from 0 to 24. Hence P2's waiting time is 24. So what's the waiting time of P3? It has waited from 0 to 27 because it is allowed only after execution of P1 and P2. Hence it has been waited for 27 seconds. Okay, I repeat here, 27 time units. So now how to calculate average waiting time? See this, P1 waiting time is 0 plus P2 waiting time is 24 plus P3 waiting time is 27. 0 plus 24 plus 27. So whole divided by 3 because I wanted to calculate average. So average always means divide by number of processes. So if I divide the sum, which is a 51 whole divided by 3, I will get a 17 seconds. That's average waiting time. So it doesn't mean all processes waited exactly for 17 seconds. So some process has waited for no time, some process has waited for long time, but on an average 17. See, if a student, some student has got 10 marks in the examination out of 100, another student has got 90 marks in the examination, it doesn't mean okay all student has got exactly between this. So whatever is starting by smallest value to the highest value, that's called range. So that is a average. Okay, so now the second concept, if we change the order of arrival of a processes, what it may result into. So now the processes order has changed. Earlier it was 1 P1 P2 P3, now it is P2 P3 P1. I repeat, P2 P3 P1. So what is the algorithm here? Algorithm remains same, FCFS, but arrangement of ordered occurrence of processes changed. So what is the first process occur? P2. Okay, what is the arrival time, what is the burst time of P2? 3. Okay, so here I will write P2's burst time is 3. So then P3's burst time is also 3. P1 burst time is longest, that's a 24. Okay, now the question, who will come first according to the given order is P2. So what I do, I will put up one rectangular box without vertical lines initially. First I will put one vertical line towards my leftmost and call it as 0. So I will check the order of the occurrence of processes. As I got to know, P2 is a first, so I will write here P2. So P2 started at 0, that I understood. So where I should stop P2? When I should stop P2 is when P2 value P2 has executed for 3 continuous seconds of a time. 3 continuous seconds of a time. So 0 to 1, 1 to 2, 2 to 3, like this 3 continuous time units. So P2 has completed. After P2 I can delete this because P2 is no more. So who is the next? P3. So what is the time of P3? It is the total burst time is 3. So when I am allowed to start it, I am allowed to start it only after P2. So when P2 has completed is 3. So I am allowed to start only after 3. So hence 3 to 4, 4 to 5, 5 to 6. These are the 3 time units when P3 will execute. Hence what is the starting time and end time of P3 is? P3's start time is 3. P3's completion time is 6. Hence P3's total execution time is 6 minus 3, which we can write also as 3. So after this P3 completes, what is there in the given order? P1. So I know that P1 total execution time is 24. So P1 is allowed only after P3 completion. P3 was allowed only after completion of P2. Hence indirectly when P1 occurred, completion of P3, also completion of P2. So when P3 and P2 both were completed is 6th second, 6th time unit. So after 6th time unit only P1 should start execution. So if it starts execution, from where to where? It started from 6. So how much it has to move? 6 plus 24. If I go for 6 plus 24, I will end up at 30. Okay, hope the Gantt chart is clear now. So 0 to 3, 3 to 6, 6 to 30. So what's the waiting time for P2 here? Waiting time for P2, why it is 0? You can see left of it means my left, which process is there. If I refer my left, that is the waiting time. So 0. Then comes P3. P3's waiting time is 3. What about P1? P1 waiting time is 6. So P1 here. So what's the average waiting time? How to calculate? All waiting time whole divided by number of processors. 6 plus 0 plus 3, or 0 plus 3 plus 6, like that you can also do. So finally 9 divided by 9. So I repeat, sorry, 9 divided by 3, which answer is 3 seconds of a time. Earlier what was the average waiting time? 17. Now that has been reduced to 1/6th part. Okay, almost 1/6th part, that is 3 seconds. Is it clear now? FCFS. So take a process burst time and consider the order which is given. Start from the first, okay, write it from a 0th here in the Gantt chart. Allocate a CPU for full time. How much time it is required? 3 seconds. So allocate it for 3 seconds. Then you write one vertical line which shows end of P2. So after P2 again you refer the sequence of the order of arrival. Okay, so who is in this now, in the remaining order, who is coming first among the P3 and P1? P3 is coming first, so P3 I will write. What is the total time of P3? That's also 3 seconds. So started from 3rd, ended at 6th. So last process is P1, started as at 6, ending at somewhere. How to measure is 6 plus its burst time. 6 plus its burst time. So hence there it will end up. Okay. So for any process, whichever is in a Gantt chart, processes right or my left is a waiting time. So for P2 0 is a waiting time. For P3 3 is a waiting time. For P1 6 is a waiting time. Hence 0 plus 6 plus 3 whole divided by 3 I have to do. That will give us 9 divided by 3, which is equal to 3. So average waiting time for the process set which using FCFS algorithm for the processes P1, P2, P3 whose burst time is 24, 3 and 3. Using this order, we will get an average waiting time as 3 seconds. Okay, next, second algorithm, shortest job first. Okay, shortest job first. I hope we all you all stood in the school days for prayer. Okay, for the prayer morning, whenever we used to enter the classroom, we used to do prayer, national anthem, etc. Who used to stand first? Short fellow. At the last, who is the taller? Same way. So once the questions means processes and their burst time is given, first only identify who is the shortest and who is the longest. So go on allocation of that. Okay, I hope it is clear now. Very simple way. Who is a short? He is first. Again smaller, next smaller, smaller. Finally end up with more duration. So here one problem is given, P1, P2, P3, P4. So what is the burst time? 6, 8, 7, 3. So now don't worry about a process number. Concentrate only on burst time. So who is a who has a small burst time? That's P4. So first P4 will execute. Then what happens? Next little upper number or big number is 6. So 6 means what? P1, P4 and P1. Next we left with the two processes. One has 8, one has 7. Who has a smaller burst time? P3. So next is P3 and the last is P2, like this. Okay, now I will draw one Gantt chart like these two rows. I have not yet drawn any vertical lines. Okay, let me draw first vertical line and call it as 0. Okay, so first, what is the order I have derived? P4. So I will make P4 to sit in this. Sit means execution. So how much time I should allow that? So I have to allow it for 3 seconds. 0 to 1, 1 to 2, 2 to 3. So total of 3 seconds. At end of 3, put one vertical line. So what this third line will meaning? Third line meaning is end of P4 and start of some other process at next. So next, after P4, whom we have selected? That is P1. How much time? 6 time. So what is the starting time? 3. If started at 3 and executed for 6, what is the finishing time? Starting time plus conduction time, when execution time. Starting time is 3, execution time is 6, hence end time is 9. So put one vertical line here and call it as end of P1. Okay, so what is the present vertical line meaning? Where I have kept the cursor is end of P1, and also we should start the different one. What is the new one we should start? Check it in the order. That's P3. So P3 should start. So I will write a P3. Okay. So once I write a P3, what is very important thing? P3 started at 9. If P3 started at 9, where should be the end? 9 plus 7. 9 plus 7. What's the value? 9 plus 7, 16. So what is the definition of 16th line vertical? It's end of P3 and start of something new. So 16th we left with only one process, that's 8. So started at 16, continuing for next 8 will give us 24. So total system of the program, processes P1, P2, P3, P4 all started on specific time, ended on specific time. Total processes started at 0, ended at 24. So I repeat how I have drawn a Gantt chart again. So one horizontal line and another one parallel line I will draw, and I will write first column and call it as 0. Okay. So among this I have derived the order P4 first. So I will take a P4 and I will write here also P4. What is its burst time is 3, hence I will write here as 3 and put one vertical line. This vertical line indicates end of P4 and new thing should start. So what is a new thing? We have 3 options, P1, P2, P3. In that, looking into the remaining burst time, that's a 6, 8 and 7. Smaller is P1, which is a 6, hence I will allocate P1. So it started at 3. It will continue it will continue for 6 seconds. So 3 plus 6 is 9. Hence I will get one vertical line at 9th time duration. So what's there after 9th? Let's see. So after 9th, actually 9th means P1 completion, start of some other. So what is that new? We have to select it by this. That's a P3. So what is P3 here? P3 started at 9. I repeat, P3 started at 9, continues for next 7 time units. Started at 9, continues for next 7 time units. 9 plus 7 is 16, hence it stops at 16th time interval. Hope it is clear now. So 16th time interval, if it is completed, so we have left with only one process and which we have to start new, that's a P2. So started at 16, continue for 8. So that makes us to 24. Put one vertical line for 24, and if any line you have drawn, clip it off. So that makes execution of all the processes. So how to calculate average waiting time now? Waiting time of P1, 3. Here you can see. Waiting time of P1 is 3. Waiting time of P2 is 16. P2 is 16. I said how to calculate. So wherever the P2 is there, no, it's my left of that box. P2 my left 16. Next P3, find it out, my left 9th. So then P4 and my left is 0. 3 plus 16 19, 19 plus 9 28, 28 whole divided by 4 is 7 time units. So let's take time unit as second. Okay, so actually problems will be in terms of milliseconds actually. Okay, so we are going to get the problem in this unit soon. Hope it is clear now. Shortest job first. Okay, now comes slightly expanded algorithm. It's not same like the previous. It is a shortest remaining time. This is slight important, and also we have to think and answer this type of question. Okay, we cannot answer orally, we have to think and decide. Okay, now this is called shortest remaining time. Shortest remaining time. Now so far what we got is processes column and a burst time. Now we have to think, please carefully listen. Now we have to think, we get one more data called arrival time. Okay, listen carefully. What do you mean by arrival time? It's a time unit on x-axis, as it is as I explained previously, time unit on x-axis, which mentions or which gives us at what time process is going to arrive. If one process arrive, listen, if one process arrive, we have to pause presently executing process and decide, should I continue presently executing process or should I opt other process based upon, very important, their remaining time. If present process remaining time is lesser than newly arrived process, I'll continue the present process. If present process remaining time is more than newly arrived process, cancel the present process and allocate resources for newly arrived process because it has less remaining time. Okay, now 4 processes, their burst time 8, 4, 9, 5, just like the previous. I think here it was, okay, no, fine, it was a different value, 8, 4, 9, 5. So if you don't have arrival time, so then definitely it's not a shortest remaining time, it is going to be SJF. So how you will solve SJF? That means shortest job first. Think for a while. So among all the 4, who is smaller? P2 is smaller, so P2 will come first. Okay, then next smaller P4 will come second. Next smaller P1 will come third, and last smaller, or we can call it as biggest, is P3, and last is a P3. But here there is a definition is different. Shortest remaining, after every new process arrive, please calculate remaining time of all the processes. Who is small, that we have to pick for execution. Okay, also we have to concentrate at what time a process is approaching for execution. So here 4 processes, P1, P2, P3, P4, they all arrive at a different time called 0, 1, 2, 3, and they are going to use CPU for this much amount of a time. So now the condition, please listen. If arrival time, if the time instance we are discussing is 0, that is a first vertical line, we should never bother about P2, P3, P4 because they are going to occur or arrive late. Late means what? After first second, after second second, after third second. But we are discussing now what? Now we are discussing 0. At 0th second, okay, who has arrived? At 0th second, who has arrived? Only P1 has arrived. So if P1 is arrived, even though it has moderate burst time, since no other processes has reached for a computation, no other process is there for a computation, so who will get the resource is P1 itself, even though he has a 8 burst time. Since there is no other comparison, the comparison starts at next time. Okay, right now, which means 0th second, there is no other comparison, so I will allocate P1. So if I allocate P1, okay, for how much time I should allocate? I have to allocate temporarily for 1 second. So 1 second I have allocated. Exactly at this moment, who will come? Exactly at this time, that is a first time unit, who will come? P2 will come. Now you should think, please listen, now you should compare whether newly arrived process burst time is lesser, or the process who has executed for 1 second. How much time? Out of 8, 1 second completed. What is remaining now? 7 is remaining. So among 7 and 4, who is smaller? Among 7 and 4, who is smaller? Because shortest job. So among 7 and 4, 4 is smaller. So for next one more second, I will allocate P2.